You've already learned about the 4 points of concurrency: the circumcenter, the incenter, the orthocenter, and the centroid. So today we're going to take a little bit of time and just discover a little bit more about those points. A long time ago, a man named Leonard Euler made a discovery about those points of concurrency and proved that relationship. So we're just going to take a minute to try to see what he saw. So you'll need a straight edge and a compass. You look at the triangle that's drawn on the top of your paper. I already had the computer construct the points of concurrency, so you wouldn't have to do that, but you could do that completely on your own as well. Construct all of those points of concurrency on one triangle. Today, since we are just going to try to discover a little bit more about those, I didn't think it was necessary, but you are welcome to do that. So take your straight edge and just line it up with these. You don't necessarily have to draw a line just yet, but we'll just go through this list here. So using your straight edge, line up your incenter and your circumcenter. And so this is what Euler did. He just started thinking about stuff. What's going on with these? Is there any special relationship? And maybe don't draw that line yet. I have to draw mine to show that, but we get that idea. Line up the incenter and the orthocenter. Line up the incenter and the centroid. Line up the circumcenter and the orthocenter. And is there anything that you notice? And let's move that. Line up the circumcenter and the centroid. And hopefully you realize something about all three of those points. Go to this triangle below and see if what you're thinking about is true. So if you're trying to discover something, you'll try several different types of triangles and eventually prove it. But for us, at least if we're looking at different kinds of triangles, we can start to convince ourselves that it'll work on every case. You wouldn't want to try an equilateral triangle or an isosceles because you want to see that it works on every case. So the one at the bottom of the page looks like this. Hopefully you got a chance to check it and you realize that when you connect your orthocenter, your centroid, and your circumcenter, they always seem to line up. I can move this triangle around so it looks different than the one you had on the paper, and there's that line if you notice that those points are always collinear. The screen got moved on me there. But the points are always collinear even when that orthocenter and circumcenter outside. Also notice where the centroid is located compared to them. So it's kind of becoming a little more equilateral here. Obtuse. Trying to make it right here. Notice where that orthocenter and circumcenter is. So this is what Euler did. He was just kind of noticing things. He did some discoveries and he figured some things out. So that's trying to make it a right triangle there. And then as it becomes more equilateral, we've already kind of just seen that those points will go on top of each other, but they'll also line up. I don't know how well I'll do with that. So what we just discovered is that those 3 points line up. So let's make sure that we have them labeled correctly. I remember it as the OCC. So the orthocenter, the centroid, and the circumcenter are the 3 points of concurrency that always lie on a line. There's something else that's special about those 3 points. And so we know they form the Euler line. They also form the Euler segment, if you imagine it just stopping at the orthocenter and the circumcenter. And we want to notice the ratio between those segments. So go back to your drawing, use your compass, and let's measure. So I'm going to use my compass to measure so it's a little more accurate. It'd probably be a little bit better if these points were smaller. So try to go to the center of that point and measure the distance between the circumcenter and the centroid. Make it as accurate as possible. And notice that between the centroid and the orthocenter. You know what? I need to draw my line. If you haven't drawn your line yet, connect your OCC, your orthocenter, your centroid, and your circumcenter. It can extend out, but the segment is just this part. Okay, so I'm going to double check that measurement, make sure my compass didn't get bumped. So there's the distance between the orthocenter and the centroid. And I am going to mark that off. And I'm going to measure the distance between that marking and the orthocenter and see if I notice anything. If I have an idea what I think is going on, I could go to the next one because you're making a discovery. You want to make sure it works for all. Connect your orthocenter, your centroid, and your circumcenter. So we just created our Euler segment. Measure the distance. Again, I'm going to try to put that pin right in the center of those points since the points are so large. And connect or measure that distance and see if it's what I thought it was. Oops. Didn't make that arc big enough. You want a point of intersection that you can see. There we go. And then mark that off. And I notice that these two distances add up to the other one. So it looks like if we consider all of these one length, whatever it is, 1, 1, and 1, they are always in a ratio of 2 to 1 or 1 to 2, depending on your point of view. Since you may not be completely convinced since we only did 2 triangles, I do want to show you the electronic version of this. So here we've got, looks like A would be, I'm going to make a guess on what point of concurrency that is. Looks like that's an altitude, so A is your orthocenter. The B point contains this line that goes to the midpoint of the opposite side and this line that goes to the midpoint of the opposite side. So it looks like that's the centroid. And C looks like it's a circumcenter. We've got perpendicular bisectors that are connected there. So if you notice those, and watch the numbers up here and the relationship of AB to BC, which is at the bottom. So I'm going to move the triangle and just kind of watch those numbers. So between AB and BC is the relationship what you thought it was, whether it's the ratio or even those numbers. So wherever I stop here, even if they're on the outside, notice that ratio of AB to BC never changes. And B is also staying right in the middle there. So the last part of our discovery here, after we measured, we compared the parts of the Euler segment, and the question was, what's the ratio? I think the best way to say that is that it is in ratio 2 to 1. Or depending on your point of view, you really could say 1 to 2. Either one would be wrong as long as you realize that there's 2 parts on one side and 1 part on the other. So our middle point was always the centroid. So we could say from the centroid's point of view, the centroid divides the Euler segment into 2 parts so that that smaller part is half the larger part. So go ahead and try the problem at the bottom that says step 5 and use your conjecture to solve this problem. Pause the video, try it, get an answer, and then I'll show you how I thought it through. Alright, it says that AC, segment AC is an Euler segment containing the 3 points of concurrency A, B, and C. And it also tells me that AB is greater than BC, and that's important since we can't really trust the drawings of the geometry. We want to know the rules. So as long as we know AB is greater than BC, and it's an Euler segment, and those are points of concurrency, we know the relationship. So it tells me that AC is 24 meters, so I am going to add to my drawing. So if the whole thing's 24, and I know if it's in ratio 2 to 1, then there has to be 3 parts within it. So I'm going to divide my 24, divide by 3, and I know that's 8. So that tells me, since the smaller part has to be half of the larger part, if this was 8 and this was 16, and since 8 plus 16 is 24, I have the division correctly. So now I know AB should be 16 and BC is 8. Always draw on your pictures, write on your pictures. It really does help you to figure things out. When you come to class next time, you can practice the Euler segment. You can put that in your project if you'd like. That's an optional thing, a little more of an advanced construction. But you may want to practice that so that you can add that to your project, which I'll be introducing to you on Tuesday.